Well, thank you everyone for your continued attention. My name is Huaxia, and I'm faculty at Simon Business School. So today I'm going to share some of my experience of teaching social media analytics. So I'm going to break my talk into 4 parts. The first part is the general design. Then I'm going to share some of the sample lab, including the code, and I'm going to share a sample case project. I call it case project. You can also call it project case. It's not a case, it's not a project, it's a case with data, like the one Ravi actually shared, similar idea. And then I'm going to share with you some of the lessons that I've been thinking about, some with solution, some without solution. Okay, so a little bit background about this course. I started developing this new course, Social Media Analytics, at Simon Business School in 2014 in an effort to help Simon students understand and analyze social media in the business context. Well, actually, that's not entirely true because Avi and Rajiv asked me to do that. So I didn't volunteer to develop this course. He asked me to do that. I must admit, at the first, I was a bit reluctant because I was already teaching 2 MBA courses at the time. I feel like, well, as a junior faculty, why should I develop a new course? But over the years, I started to realize this is really a great idea. Not just in terms of teaching, but also in terms of synergy between teaching and research. Some of you probably can recognize some of the footprint of my research papers in some of the projects that I share. So we offered this course 3 times throughout the past few years. The first time we had about 20, it's elective, so students make their choice. First time we had 25 students, 1 section. Most of them MBA students. Second time, we had 77 students, 2 sections. We broke them into 2 parts, 37 for the BA, MS student, and 40 in the MBA section. The reason we want to separate them because they have different technical background. So it makes the teaching a bit easier. And the last time, which is actually, I just finished it 2 days ago. That's why my voice a little bit weird. We had 2 sections with a total of 133 students. I put all the MS students, including MS in Business Analytics and MS in Marketing Analytics, into 1 section, the same section with 99 students. The other section remains just for the MBA, about 34 students. Again, the reason is just because the different background, it makes teaching easier. So that's the background about this course. And some course highlights. It's a very hands-on course, a mixture of lectures and labs. I chose R as programming language mainly because it's to be consistent with the language choice the school adopts, both inside our MSBA, MSMA, and also for the MBA program. So that's not so surprising. But what I did, I think that's very important. It's a really big choice when I think about using a cloud-based RStudio environment instead of a local version of RStudio environment. I'll give you reasons why. But during the talk or after talk, you can use any of these servers. Just log in, here the username, here the password. But right now, I just created one user for each server for you guys. So if 2 of you log on the same server, 1 of you is going to be kicked up by the other person. So we need some coordination if you want to try it during the talk. I can quickly show you. Just use the any internet browser like this one. This is what I did. I logged in. So if you try, I share my code through that platform. So let me give you my rationale why I did this. Because I want to try different packages, and especially those new packages, new techniques. And if I teach 133 students, each of them with different operating system, different environment, different habits, and all kinds of stupid things they did, then it'll take, I don't know, 10 TA to fix all their problems. And it's not scalable. What I did in this manner is basically students, they are isolated from any environment issue. They isolate from any package issue. I install all the packages for them already before the class starts. And isolate myself and my TA from spending time solving those problems for them. So that's a big decision. And to implement that, I have this set up in my office. So basically, it's basically a cluster. This is my data server. As you can see, I have like 18 hard drives, each with 8 terabytes of size. And this is my front-end web server. So if you log into any of the R1 through R9 server, they share the same IP address. So then I basically direct the traffic to different nodes. These are 5 of the nodes. I have 4 other nodes in Texas, actually. So just for redundancy, and in case someone breaks to my office and did something. So this is the infrastructure. I think that echoes back to Ramesh's point of can we have some kind of infrastructure so that everyone can use it? And this is like the first attempt for my own course. And also, I'm thinking about this for all the courses we teach at Simon School, especially for some big data course or some course that requires a real physical cluster environment. So that's the hardware. Now, in terms of software design, it's also very simple. It's simple. I just have one front-end server that accepts all the traffic from students. Then it directs to internal servers, each running an RStudio server. And these all have a private address, so they are not exposed to any internet attack or anything. I just have to make sure one server, the front-end server, is securely protected. Then I have an internal data server, which stores like terabytes of data. And the OS, I use a mix of CentOS 6.5 and STEP 7.0, but I'm migrating to 7.0 after the semester is over. So basically, that's the design, the infrastructure design of this course. And I also want to point out there's a potential of monitoring whatever students do in this class by looking at the code they execute, whatever they do in the server. It can give you some more information to have, like teaching analytics. Correlate that with their grade, for example. How they learn, how much time, how often they log on, how much time do they spend on each server every time they log on. So I haven't done any of that, but I think that could be a potential for some teaching innovation in the future. Okay, so you also need some administration program. I wrote quite a few. They're basically, I got an enrollment list from the school system. Then I wrote a program already that can directly read those files of these student information and then create an account on each of those clusters and populate and also distribute all the data in that folder. Maintenance, I will just talk a little bit at the end. So that's basically the infrastructure of this course, which has nothing to do with the content at the moment. So now this is the basic content topic that I covered in this course. I have the 3 basic components. First component has little to do with data. So it's basic social media marketing. I gave them the conceptual framework of offensive marketing and defensive marketing. So on social media, offensive marketing basically like brand campaigns, hashtag campaigns. The defensive marketing are basically the customer service on social media, which is on the rise. Then I talk about the text analytics part, including how you manage data in R, how do you do the traditional linguistic analysis, how do you represent semantics, RSA, topic modeling, supervised topic modeling, etc. And then I also talk about the classification. So also this is a relatively new part which I added last year. But basically I'm applying deep learning stuff to do the textual analytics. I do some of the word to vector, especially the skip grant, and I also discussed a little bit of LSTM. So now, in terms of structure, every time I basically spend half the class lecturing the idea, theory, algorithm for each topic. Then the other half of the time, they are given some data and some tasks, and they do it in groups. And I also I require my TA to sit in my class in the second part so that my TA and I can walk around and to help students. And the homework and exam, homework is similar to the lab, but exam that turns out to be more challenging. So I'll give you 2 examples of exam I gave. This is one example. This is for this year. Basically, I just gave them a bunch of data, then ask one simple question. Find out all these data are basically tweets sent by customer to airline. Ask them one simple question. Find out those tweets that are not complaints. You cannot do it manually. I don't care how they do it. I just give them 2 hours, the data, and they do it. So so I try to create a more like an interview type of environment for them to test them. And also this is like another type of exam take-home project, not in the class. So for example, I did this last time. I asked each student to select a brand he or she is interested in, and they are mutually exclusive. So two students cannot select the same brand. So once they select the brand, they submit the keywords, whatever keywords they want, and through a web interface that I gave them, then they will receive a link to download about 1% of all the tweets containing those keywords from 2011 until whichever month is the last month. Then their job is to analyze those topics and sentiment or whatever, and then they have to submit a report. So that's the final take-home project I gave them last year. Okay, now I'm going to share with you some of the labs that I did. So the first lab, in this one, I gave each student 300 documents. These are all reviews written by patients about some doctors. And then I asked them to use LSA. I talk about idea and sample code. Then I asked them to use LS to analyze the corpus and construct a two-dimensional representation for each document. Then I asked them to use a clustering algorithm to cluster them into 3 clusters, and then compare with the actual content to see if they make sense. And this is the result from that lab. Basically, as you can see, because I have the ground truth, I know what kind of doctor each review is about. So here, this two-dimensional. So basically, each student represents a document with 2 numbers in a 2-dimensional semantic space. So that's the green one. That's OB doctor. The blue, that's the pediatrician, and that's dentist. So you can see clearly that dentist is sort of it's separated from the other 2 types. But the other 2 types, they are really not separable in this 2-dimensional feature space. And we all know that makes sense because of the pediatrician and OB doc, they are working on similar type of people. Okay, then this is another lab, the Ebola lab. I created that during the time when Ebola was a problem. So that's just a little background. September 30, 2014, that's the first confirmed Ebola case in the US. So I gave them the data for starting from the next day in October 2014. So that's just from the word cloud of those tweets for 1 day, October 14th. So I give them that. Then I ask them, can you use the LDA, the latent duration allocation algorithm, to find out different topics, to cluster the document into different categories. And they can do it using that. And here are some examples of different topics. This is one of sample topic. That's another sample topic. And that's another sample topic. So these topics, because we know what happened, so we can make sense of it. But think about if you are an alien just landing on this planet, you have no idea, and looking at this basically, the clustering gives the student an idea of how to automatically discover underlying topics. So that's the second lab I discussed. And here's another one. This one is, I didn't tell students anything. I just gave them data with an hour of an hour of random tweets in some day in 2014. And asked them to discover the topic without looking at the content. Now, the first thing they did is to create a word cloud, and they didn't find anything. Then they started using topic modeling to try to figure out what's in there. And they found, okay, here's a topic. Some people know it, some people don't. Then here's another topic. And then they suddenly realized that, okay, wow, this is a big topic. This is like the break news. It's actually about the plane, a Malaysian airline plane shut down in Ukraine. And that's at 1500. And if you look at the route of that airline, you see that's roughly after 1300, that's the accident. And you can use algorithm to detect that event within 2 hours. That's before any news break by major news agency. So I use this example to just give students an idea of how to use various techniques to detect topics. And here's the last one, which is about the deep learning. I gave them the theoretical background of this skip grant thing. And then I give them some data. They use the data to train a neural network model. And then eventually, this is just a snippet of millions of text. And then after that, you create the vector representation for each of the word. And then, because each word now is represented as vector, you can plot them. And then, you, surprisingly, a student can appreciate the idea that without any human supervision, this abstract concept of capital can be learned just by reading text. So that's like how baby learn language in the first place. You don't teach them. They just get a lot of input and they learn it. So you can do some kind of interesting or maybe bizarre algebra like that. And so my point is, every time I introduce a topic, there's always two parts. The theory part, like that, and also the data and analytics part, so that they get an impression of how it actually works and what are the outcomes. Okay, so I'm short on time. I'm going to talk. I want to spend more time on the sample case project. So those labs are done during the class. Sample case project, they are more involved than a lab. So basically, there's some deeper and more interesting discussion, more than just the data. And that is particularly popular among MBA students. So the background is social media customer service. I have some examples here. That's me complaining to UPS about some package issue. So a lot of companies are actually using social media, especially Twitter, to provide a customer service to interact with them. That's like the trend. But the interesting thing is something like that. If you notice, these are two tweets complaining about exactly the same issue. One of them get a response, one of them don't. So if you think about a traditional call center, you call, you get a response. It's just a matter of how long you wait. But here in this case, they're not. Actually, more than 50% of those customer complaints are not responded. So at this point, I introduce the student, or I challenge the student to think about why are some of those responded? Why are some of those not? Why are not all customers created equally? So then I give them some material, articles from Forbes or MIT Technology Review, basically giving them the background that a lot of companies are using various techniques to include the influence level of each customer into their customer service solution. So then we did something in the class. Actually, during the class, we just do it in live. By asking airlines, for example, I'll ask airline that, well, if you look at this one, basically they're saying we're not doing any kind of influence-based prioritization. So we asked airline directly in the class, are you doing something like that, or it's just the first in, first out? And that's the answer from Ask Airline. We also did that with United Airlines, and they refused to answer that question. So then I did two polls in the class. First, I asked, not at the same time, I asked some of the students, if you are a customer, do you think it's fair to be prioritized based on how influential you are on social media? And students, they all voted no. I don't want that. Especially, I got a lot of vigorous response from students from minority. They feel particularly offended by this idea that just because I'm less influential, I'm going to treat it differently. So that's one result. Then I asked another group of students. They are randomly selected. Do you want to do that if you're a manager? And they all said, yes, I want to do it. So that creates a dilemma. And it actually has two questions. First is, should they do it? The second question, do they do it? And then the MBA student like this one very much. And MS student, they like this one very much. Because that involves data, that involves a lot of debate. So then I gave them this interesting thing from Twitter. This is actually from Twitter. You can download this customer service on Twitter playbook published by Twitter. And if you read that, you say, whichever prioritization criteria you choose, be sure they pass the sniff test. If the criteria become public, will they embarrass you? And blah, blah, blah. And then they eventually said people can do reverse engineering to reconstruct your prioritization policy. So we said, OK, why don't we just reconstruct that? And that's what we did for the second question. And also, then I lead a discussion about the first question. Prioritization is part of our life. Why sometimes we feel okay, sometimes we don't feel okay. If someone pay more for the airline ticket, you can board first. That's fine. People feel okay. But in this circumstance, why do people feel offended? So then I introduced first the behavioral economics, the behavioral economics, and these are two quotes that I shared with the students. And a lot of them get very excited by this kind of new angle of looking at behavior. So these are both from Daniel Kahneman, one of the Nobel Prize winners in economics. So the idea is that traditional economic theory, they don't consider anything about fairness. But customers, they do. And sometimes companies, they can give up any legal but unfair profit, either because the owners or managers prefer acting fairly, or because they are concerned the customer may be unhappy of the unfair practice. So then I introduced another important theory from social psychology. That's from Martin Dewis. He actually just passed away, I think, last month. About why do we feel something is fair and why do we feel something is not fair? So according to this social psychology theory, there are three basic principles. The equity principle, basically, if you contribute more, you get more. If I pay more for my ticket, I get a better service. The equality principle, which basically everyone should be treated similarly. A need-based principle, which is basically in certain circumstances, I need more help to improve my life, and the government or in general community can tolerate need-based principle. And the reason why all the students feel offended by this influence-based prioritization is because this kind of prioritization violates all these three principles according to social psychology. So that's the normative question, which the MBAs really loved. We had a great debate every time I taught that case. And then we had the positive question. Basically, I gave them data. And these are data I collected from over the past few years. And they are asked to develop a sentiment classifier to extract those complaining tweets, then identify initial tweets using latent semantic analysis to reduce dimensionality, doing some clustering, and then eventually do some econometric model. So that's the result. And I showed them, well, in fact, they are actually doing that. OK, so I have 2 more minutes. I'm going to share with you some of the lessons. So these are some just very detailed lessons. I had some failure, but they are always solutions. I like the cloud setup so that nobody has to worry. We just have to have one person worry about the cloud setup, and everyone else is freed from all those hassles. Secondly, don't use any more than 2 public IP. You don't need that. Just 1. That's enough. And don't use RStudio Server Professional. First of all, well, actually, it's also free for academics. But even that, I don't like to use it because they have some issue with the license. And when a lot of student access, it could create a bottleneck, which can bring down a machine. So node fail. They always fail. Before the exam, one of my nodes failed, but they still have 8 choices. These are just some of the detail. My last lesson is something I don't have any solution. Basically, our job is not to make the student comfortable, but make them employable. So we have to teach them more than just what they can gather by looking at the Wikipedia page. They have to delve deeper into the techniques, or sometimes even the underlying mathematics. But the question is, we always feel we have the pressure sometimes from the dean's office of keeping students happy no matter what. So that creates a dilemma. I always feel like, okay, should we push this or not push that? It's like something I always face in my daily life. How do you keep the kids happy without giving them the candies? Okay, thank you very much for the attention, and I rushed a little. Oh, one last thing. Let me just show you quickly. So you can just use R1 through R9, except R4, which is down, the node server that failed. And I have the code. And you can just try it, or let me know if you have any questions. You're going to set that for all of them? I can easily do that. I was planning to. Yeah, well, Give me the enrollment list.
All right.
Yeah.
So some of these like server data sets you need
Yeah.
how do you access it? Do you share that or?
Yeah, I can share that. So because right now I have some the easiest way I just put the file, but most of the data in the database. I can just give you the database credential, then I can log in from the R Studio. That's how I did it in the class. No, I collected since 2011.
Now you can only track the past.
I know, but I've been collecting since 2011.
Yeah, that's what I mean. So continuously.
Yeah, I can do it for 7 years.
But you will what keyword?
I used something called splitter. It's 1% of everything. 1% of random. Random. That's so it has. That's why I have so many disks over there because there are like several billion.